evaluate the definite integral. So I'm going to start here just by separating this out into two pieces. We have this 4 over x, and then we have our exponential. So let's rewrite this as the definite integral from 1 to 4 of 4 divided by x dx minus the definite integral from 1 to 4 of the natural exponential raised to that negative x dx. And we could even rewrite this one step further, and we can factor this common 4 out in the numerator of our first definite integral. And think of this as 4 times the integral from 1 to 4 of 1 over x dx minus the definite integral from 1 to 4 of the natural exponential raised to the minus x dx. And so now both of these definite integrals are in their most general form of antiderivatives. So this integrates to 4 multiplied by the natural logarithm of the absolute value of x, and then we have minus the natural exponential raised to the minus x divided by negative 1, and we're ready to evaluate from 1 to 4. And so I pulled those bounds out in front of both of our terms because they both have the same bounds. So we can rewrite this again. Negative divided by negative becomes positive, and we have 4 times the natural logarithm of the absolute value plus the natural exponential raised to the negative 1, and we evaluate from 1 to 4. So here we go. We have 4 multiplied by the natural logarithm of 4. So notice I drop the absolute value bars as soon as we know it's positive, it can't be negative, plus the natural exponential raised to the negative 4, and then we're subtracting the evaluation at the lower bounds. So this is 4 multiplied by the natural logarithm of 1 plus the natural exponential raised to the negative 1. And so looking at this, we know that the natural log of 1 is 0. And we also notice that we can rewrite 4 as a perfect square. So we can rewrite this as 4 times the natural logarithm of 2 squared plus the natural exponential raised to the negative 4 minus the natural exponential raised to the negative 4. And by properties of logarithms, we can take this power of 2 and bring it to the outside of the logarithm. So this becomes 2 times 4, which equals 8, times the natural logarithm of 2 plus the natural exponential raised to the negative 4 minus that natural exponential raised to the negative 1. And this is our beautiful final answer. And again, I assumed my properties of logarithms here, but just in case you haven't seen them in a while, remember that the natural logarithm of a power, so we have some a raised to a power of b, is equivalent to b times the natural logarithm of a. And so that was the logarithmic power we applied here to the natural log of 4 to give us that beautiful final answer.